All right, today we're going to do exercise 1.18 from chapter 1 of a number 3 textbook. It says assume that a to the b minus 1 is a prime where a, b isn't natural numbers, b greater than or equal to 2. Show that a equals 2 and b is prime. Primes of this form are called Mersenne primes. Most of the largest known primes are Mersenne primes, probably because they're pretty straightforward to calculate. Okay, so let's consider the expression a to the b minus 1. Okay, so immediately something should jump out to us, and that we can factor this expression explicitly. Okay, so in general, if I have a difference of squares x to the n minus y to the n, this can be written as x minus y times x to the n minus 1 y plus x to the n minus 2 y squared plus plus, or excuse me, I got this slightly wrong. So x to the n minus 1 plus x to the n minus 2 times y plus, I can go one more out just so you can see, x to the n minus 3 times y squared plus plus all the way down to y to the n minus 1, okay? And so hopefully you've seen this factorization before. If not, you should look up difference of, nth power factorization. It's a very important formula to know. So we notice that we can write a to the b minus 1 as a to the b minus 1 to the b, right? And then I can just factor this. So I have a minus 1 times a to the b minus 1 plus a to the b minus 2. Excuse me, a to the b minus 2 plus all the way down to 1. Okay? And so immediately by factoring this number, if we want a to the b minus 1 to be prime, then we need to require that it has no non-trivial factors. In particular, a minus 1 must be non-trivial. Must be trivial, excuse me. It's non-trivial. If it's a non-trivial factor, then a to the b minus 1 can't be prime. So that means that a minus 1 is equal to 1, and so a is equal to 2. All right, and so that's the first part of the problem, is that a equals 2. All right, now the second part follows from a similar form. So we have now 2 to the b minus 1, and we've shown that this can be factored as 2 minus 1, which is, I'm not even going to write out that factorization, it's trivial. So now suppose that b is not prime, okay? So let's write 2 to the ab, okay, like this. And suppose we have a composite number in the exponent of the 2. Now I can use the same exact trick where I view this as 2 to the a, all to the power of b, minus 1. So I'm just going to expand again, using that same expansion of the difference of, nth powers. And so I have 2 to the a minus 1 times 2 to the a b minus a, which is 2 to the a to the b minus 1, plus 2 to the ab minus 2a, plus plus 1. And so now I conclude that, well, this factor has to be trivial, because we want this thing to be prime, right? We want this to be a prime number. We want this to be prime. So therefore, this must be 2 to the a minus 1 must be a trivial factor. In particular, 2 to the a minus 1 must equal 1. Well, that tells us immediately that a has to equal 1. And therefore, b, this exponent, can't be composite. Okay? We've basically shown that we can never factor the exponent into two terms that one of them isn't 1. Okay? And so that literally finishes the problem. And so I hope you enjoyed that, and I'll see you in the next video.